Okay, this is Mr. Hanna with lesson 3-3, which is on pages 170 through 174. We're talking about rate of change and slope. And this is probably the single most important lesson that you will have this year in Algebra 1. So please pay attention. Rate of change is a ratio. It's a fraction of how much one quantity changes as compared to another quantity, and how it changes. We have lots of different names for the same thing. Rate of change is equal to the change in y over the change in x. This triangle-looking thing is a delta. That's a Greek letter. In math and in science, that means change. So delta y over delta x. How do we find the change? We subtract the y's and the x's. Now notice y2, x2, y1, x1. Those guys have to go together. These guys have to go together. We also call it slope, or rise over run, or we use the symbol m, and nobody knows why this French guy back in the 1700s picked m for slope. He didn't tell people why. So that's all we know is he used it. We don't know why he used m. Slope is always constant, which means the same for a given line. Now later on we'll talk about some things where you've got line segments, but that's different lines. So if we want to find the rate of change from a table, this is like example 1 on page 170. You just pick two pairs. You put the y's on top, you put the x's on bottom. Make sure the top number is in the same place as its matching bottom number. So I've got a table, floor tiles versus area tiled surface in inches squared. My x's, this is the number of floor tiles, 3, 6, and 9. My y's, this is the surface area covered by them, 48 square inches, 96 square inches, 144 square inches. I chose to use the last two pairs, the 696 and the 9144. So notice, 144 goes with 9, so both of them are in front. 96 goes with 6, so both of them are in back. I got my x's on bottom, I got my y's on top. That's very important. 144 minus 96 is 48. 9 minus 6 is 3. And 48 divided by 3 is 16. So the rate of change is 16. But they also ask you to explain the meaning of the rate of change. So then you got to come back up here and look at what these things are talking about. This one is talking about number of floor tiles. This one is talking about the area, the surface area that is tiled. Well, if we have a rate of change of 16, that means for each new tile that we add, we cover 16 inches squared of surface. So if we're covering 16 square inches of surface and it's a square tile, that would be a 4 by 4. Although it doesn't say they're 4 by 4s, it doesn't say they're squares. These could be rectangles. It could be a 2 by 8. You never know. Now, example 2 on page 177. I'm not going to draw you a picture, but you've got connected line segments. And each segment will have a different slope. So you use the endpoints of each segment. You find the one on the left and the one on the right, get your x and y coordinates, and you use them to find the rate of change. Now each segment will have its own rate of change, so you're going to have to do that for each segment. Some of the problems, they're going to want you to find the least rate of change. So you're looking for the flattest part, because the flattest part will have the smallest change in the y's compared to change in the x's. If you want the greatest rate of change, you find the steepest part, because the faster it's going up, that means the y's are getting bigger over a smaller x. So that's your steepest part and your greatest rate of change. Now, like example 3 on page 172, some of your problems are asking, is the function linear? Linear means, does it make a line when we graph the solutions? So you will recall that I said earlier, that the rate of change for any line is constant, the same. So if we want to know if it's linear, we use this fact. And we have to find the rate of change between every pair of points. And if it's linear, then they should all be the same. And I did two examples, one which is not linear and one which is linear. So I have a table, x and y. I've got -3 and 11, -2 and 15, -1 and 19, 1 and 23, and 2 and 27. So you may be wondering why I have these numbers out here and these numbers out here. Well, remember we had the change in the y's, so from 11 to 15 it changes by 4. Over the change in the x's, so from -3 to -2 it goes up by 1. So I put the y over the x, the 4 over the 1 is 4. It reduces 2. The next one from 15 to 19 again goes up by 4. From -2 to -1 again goes up by 1. So again I have 4 over 1, still 4, still good. The next one, 19 to 23, is going up by 4 again. So far so good. But from -1 to 1, it goes up by 2. And when I put 4 over 2, I get 2. If all they want to know is if this is linear, I don't even have to check the next pair. 23 to 27 is 4, 1 to 2 is 1, but 4 over 1 is still 4, but they're not all the same. As soon as I get this one that's different than these others, check my work to make sure I'm right, but they're not the same, so it's not linear. On this example, though, if you look, I'm going from 12 to 9 to 6 to 3 to 0. So the x's every single time are going down by 3. The y's, -4 to 1 goes up by 5. 1 to 6, up by 5. 6 to 11, up by 5. 11 to 16, up by 5. I can go ahead and put all of these 5s over all of these -3s, but if these are all the same and these are all the same, then you know these all have to be the same, so it is linear because we have a constant slope. Now, they tell you in the book, a vertical line has undefined or no slope. It's undefined because we can't divide by 0. In vertical lines, all of the x's are the same. If we have a vertical line, that's an x-coordinate, and all of these x-coordinates are the same. So remember, since we're subtracting the x's, we get a 0 on bottom. And remember, we can't divide by 0. Okay? So the slope for a non-vertical line is the change in the y's over the change in the x's, or y2 minus y1 over x2 minus x1. So if you have something like this bad boy, it's going up from left to right. That is defined as a positive slope. You have this one, it's going down from left to right. It's a negative slope because the y's are going down as the x's are going up. Positive slope, the y's are getting bigger as the x's are getting bigger. Told you already that if it is a horizontal line, it will be parallel to the x-axis. Then it has 0 slope. The equation of that line is y equals whatever number it is that it crosses down here. If you're looking at two pairs of points, a way to tell if you have 0 slope, the y coordinates will be the same, because then you're subtracting something from itself. You get 0 on top, which is 0. Notice I said that this one, horizontal line, which is 0 slope, is not the same as vertical line, which is no slope or undefined. All of your x-coordinates are the same. So when we subtract, we get 0 on bottom. We don't like that. To find slope, this is like example 4 on page 173. If it's from a graph, you can just count up or down and put on top of how much it went to the left or right. So I've got this graph, and this one's easy because they're crossing the intercepts. The x-intercept is -4, the y-intercept is 3. But look, always go from left to right because that's how we read. So it went up 3. Remember, rise on top of run. 3 over, it went over 4. So the slope of this particular line is 3/4. If I continued the line, I'd see that it goes over 4 more and then up 3 more. So at 4, we would be at 6 on the y coordinate. 4, 6. We'd have another point up here, and it would be in line with that one. I did one with a negative slope, too. Its intercept, -3 for the x, -2 for the y. It went down by 2, so -2. If you got to go down, it's negative. And it went over 3. So -2 goes on top of 3, and your slope is -2/3. Now, if you have points, and you need to find the slope, you use the slope formula, m equals y2 minus y1 over x2 minus x1, and it helps if you label your points. This is my first x, so that's why it's x sub 1. This is not an exponent. This is called a subscript that just keeps this x distinct from this x, distinct from any other x's we might have. So x1 is 3, y1 is 4. You could also say x sub 1, y sub 1, but that's extra talking. This one, x2 is 5 and y2 is 9. So we use these numbers and we plug them in this formula. And the more you write the formula down, the more you label these points, the more it will help you remember the formula and remember where to put them in. So I suggest to you that you do this while you're doing your homework. Okay, we don't know m. That's what we're looking for. We know y2 is 9. We've got to subtract y1, which is 4. 9 minus 4 gives us 5. On top of, x2 is 5 and x1 is 3. So 5 minus 3 is 2. I get 5 over 2. Resist the urge. Do not make that a mixed number. Because as this slope, 5 over 2, it tells us what to do. If we want to find another point on our line, we go up 5 and over 2. If we wanted to find a third point, we go up 5 more and over 2 more. So keep it as an improper fraction. I did one more example for you. I've got x1, y1, 3 and 6, x2, y2, 4 and 2. 2 minus 6 gives us -4. 4 minus 3 gives us 1. But I don't have to leave it as an improper fraction like that. As long as the denominator is 1, I can simplify that. The slope is -4. And the last slide. This is like example 6 on page 174. They give us a slope. They give us a one coordinate and another coordinate missing one of the numbers. But I have 1, 2, 3, 4 numbers and one variable. I have 5 spots. Plug them in the right. Again, it helps if you label it x1, y1, x2, y2. Okay? So I plug them in. My slope, -5, is equal to y2 minus 4, subtracted by 6, which is y1. Now, if x1 or y1 is negative, then because these formulas say minus y1 minus x1, we're going to have minus a minus in the formula, which you have to change to a plus. So I had -5 equals -4, subtract 6, r over r minus a -2. So I simplified. I got -5 equals -10, that's -4 minus 6, over r plus 2. I got to get rid of this r plus 2 on bottom because I can't solve it like that. So I got to move it to the other side by multiplying both sides by r plus 2. This one will cancel this one. They go away. I just have -10 on the right side. We've got r plus 2 times -5. I've got to distribute. -5 times r is -5r. -5 times 2 is -10. It's equal to -10, so then I have to solve it. Two-step equation, get rid of the -10 by adding. It gives me -5r equals 0, and I got to divide by -5. 0 divided by -5, anything. 0 divided by anything is 0. So the r coordinate, the coordinate we're missing, is 0. Your homework is page 175, 2 through 40 even.